Hello friends, today we are going to study about the magnetic force which is a part of electromagnetic force. We know about the fundamental forces in nature. There are four fundamental forces in nature: gravitational force, electromagnetic force, weak nuclear force and strong nuclear force. So today we will see about what is magnetic force. So if we have a charged particle Q, which is magnitude of charge is Q, which is moving in a magnetic field B with some velocity V. Velocity is V vector. Then this charged particle will experience a force. The value of that force, the equation of that force is given by F is equal to Q, magnitude of charge, multiplied with cross product of velocity with magnetic field. Here velocity vector is multiplied with magnetic field and the product is cross product. So cross product of velocity multiplied with magnetic field and again it is multiplied with the magnitude of charge will give you the magnetic force. So if F is representing magnetic force, then it will be equal to Q into V cross B. Now let us analyze this equation. F can also be written as Q and cross product of two vectors like V cross B. It can also be written as magnitude of V, magnitude of B into sine of theta, and we can take a unit vector n cap, where theta is giving you the angle between velocity vector and magnetic field. Now here n cap is giving you the direction of force. Okay, this part Q into V into B into sine theta, it will give you the magnitude of force, and n cap is giving you the direction of force. This n cap will be perpendicular to the velocity vector and this n cap is also perpendicular to the magnetic field. So basically the direction of force F will be perpendicular to V and it will be also perpendicular to B. So if we will have a charge, let us see, this is your magnitude of charge. It is moving with velocity V. This is your velocity V in a magnetic field B, and this is the angle between velocity vector and magnetic field induction. Theta is the angle between magnetic field and velocity vector. Then this F is equal to Q into V into B into sine theta. If we will write down the magnitude of force only, then F will be equal to how much? It will be equal to Q into V into B into sine of theta, where theta is giving you the angle between velocity and magnetic field. So this is the magnitude of force and direction. This n cap will give you the direction of force. N cap is perpendicular to velocity and this n cap is also perpendicular to B. So direction of magnetic field will be perpendicular to velocity vector. It will be also perpendicular to the magnetic field. Now if we will take theta is equal to 0, if we will take theta is equal to 0 dp here, means velocity vector is parallel to magnetic field, means charged particle is moving parallel to magnetic field, then how much force it will experience? It will experience a force F is equal to magnitude of force, if you will write down Q into V into B into sine of 0 degree. Sine 0 degree, the value of sine 0 degree is equal to 0. So 0 multiplied with this term, it will become 0. So when a charged particle is moving parallel to the direction of magnetic field, it will not experience any force. Now, if the charged particle is moving perpendicular to magnetic field, means theta is equal to 90 degree, how much force it will experience? It will be equal to Q into V into B into sine of 90 degree. Sine 90 degree is equal to 1. So maximum force it will experience. The charged particle will experience maximum force. And if theta is equal to 180 degree, means the charged particle is moving opposite to the direction of magnetic field, means anti-parallel, then F will be equal to Q into V into B into sine of 180 degree. Sine 180 degree is again 0. So the force will be equal to 0. So when a charged particle is moving parallel or anti-parallel to the direction of magnetic field, it will not experience any force. But when it is moving perpendicular or making some angle theta with the direction of magnetic field, it will experience a force, which is given by this equation.